In this video, we're going to discuss sequence memory models. You should already know some simple data types. The most common are numbers in their various forms, like integers and floating points or floats, and Booleans, simple true, false statements. But there are some more complex data types. Some of these are composed of elements, and you can think of elements as things that you can go through one at a time. And you may already know one or more of these types of data. For example, strings are a very common sequence, things like Harry and Ginny Weasley and he who should not be named. But there are also things like lists or vectors and data frames, and we'll cover some of these later. We'll start with strings though. Strings are a good example of a sequence. So what are the properties of a sequence? Sequences have elements, and when we're thinking about strings, those elements are the individual characters in the string. For example, Harry is composed of the letters H, A, R, R, and Y. Sequences also have length. The name Harry is 5 characters long, as you can see from the way I broke out the letters just above. If we look at a string like Ginny Weasley, that's 13 characters long. And it's important to remember that in strings, the space counts as just another character. And sequences also have order. The order of the letters is not accidental. There is very much a first letter and then a second letter and a third and so on and so on. So if we consider the name Harry, it should be no surprise that the first letter of Harry is the letter H. The second letter of Harry is A, and so on. The thing about these ordered positions of a sequence is that we can use them. We can use them to access individual elements or subsequences. And depending on the language, those ordered positions are numbered slightly differently. For example, in languages like Python, Java, the first position in any sequence is position 0, followed by 1, followed by 2. In a language like R, the first position is 1, followed by 2, followed by 3, and so on. Other than this difference in starting position, the way that we use those positions is exactly the same. So for example, if I have a sequence in R, this would be, for example, a text string. Here it is the name Harry. Then I number the positions of each element of that string, starting from the number 1. The letter H is at position 1, the letter A is at position 2. We call those positions index values or indices. And it's worth noting that for any language that starts counting at 1 for a sequence, we always know the index position of the last element because it's exactly the same as the length of the sequence. It's exactly the same in Python with that one slight difference of the starting position. Here's the same string, but in Python, that letter H would be at index position 0, the A would be at 1, the R would be at 2. And when we're dealing with languages like Python, it's always worth remembering that the index position of the last element is the length minus 1. Harry has a length of 5. The index position of the Y, the last letter, is 4. And strings are not the only sequences you'll come across. Lists or vectors are also a very common sequence, and they have some particular properties. For example, lists are heterogeneous. You can store all kinds of data in them, but they still ultimately obey the same rules. For example, lists have elements, lists have length, and lists have order. I've given you an example here of a Python list comprising 5 integers, 1 through 5. And if I were to represent that, you can see the 5 integers, 1, 2, 3, 4, 5. And here I'm representing them with Python indexing starting at 0. So at index position 0 is the integer 1. At index position 1 is the integer 2. And again, the index position of the last element is the length of the sequence minus 1. There are 5 elements in this sequence. It has length 5. The last index position is 4. And just to touch on how these things are represented in memory, there is a difference between them. Strings are represented directly. Here we're showing you the symbol table that you've seen before. On the left-hand side are the names as they're represented in the computer, and on the right-hand side is the value associated with that name. When we create a string, for example, Harry, we associate the value, Harry, with the name of the variable, in this case, name, in the table directly. But other types of sequences, and indeed other data types, are represented slightly differently. Here you can see the name of my variable, numbers, appears in the left-hand side of the symbol table. But on the right-hand side, instead of representing that information directly, what I'm doing is creating a vector of the integers 1 through 5. Instead of directly placing that into the table, I have instead a reference to those values. And that's going to be important for some things that we do later on. So things like strings, we represent directly. Things like lists and vectors, we might represent indirectly by using a reference. And that's what that arrow is there to represent. We can access elements of a sequence using those index values. So for example, if we want to access a substring, then we need to know the index values of the substring we want to extract. In the case of getting the letter H from Harry, we need to know that in R, that's the first element. So that would be at index position 1. Similarly, with numbers, the list or the vector, if we want to access the second element of that list, we need to know its index number. That would be 2 in R or 1 in Python. And there's one further piece of information. We cannot change the elements of a string because strings are immutable. So what does that mean? It means that just because I know the first element of Harry is the letter H, I cannot change the first element of Harry to be a different letter. We'll either get an error or we'll end up replacing the whole association between the variable name and the value. Conversely, we can change the elements of lists or vectors. Lists have a property in that they are mutable. We can change them. So if I try to change the second element of this vector, the value that is currently 2 to 99, it will actually change. And in R, I can do that by referencing the variable, giving it the position in square brackets that I want to change, and then making an assignment, and that will actually change the second element of that vector. And that's going to conclude us talking about the memory models of sequences for now.